In this video, we're going to go through a surface area and volume test review. We're going to be working with 3D shapes such as cylinders and cones and pyramids, etc. And we're going to go through 10 questions together. So I encourage you to pause the video, see if you can do these problems on your own, and then of course you can check them and we'll go through them together. So let's dive into this first example. We're going to find the surface area and the volume of this cylinder. So go ahead and try that one and see what you get. If you can, with all of these problems, try to put your answer in exact form. So instead of using a calculator and getting a decimal, now in some of these problems we'll have to do that. We'll be using some trigonometry as well. But if you can put it as an exact answer, do it that way. But for this first example, we've got a cylinder, and when we find the volume of a cylinder or a prism, we use this formula, area of the base times the height. So what I like to do personally is I just like to write down the general formula first, and then if I have like a sub-formula, I can put that below it. So what I mean by that is the area of the base, this is a circle, and I know that the area of a circle is pi r squared. So I'm going to replace b with pi r squared times the height. Now, in this case, I need to find the radius and I need to find the height. Well, you can see they're giving us the diameter is 8, so the radius would be half of that. It's going to be 4. So this is going to be pi times 4 squared, and then the height is going to be this dimension right here. But you can see I've got a right triangle, and so what I can do is I can do the Pythagorean theorem. I could say 8 squared plus h squared equals 10 squared, or if I recognize this as a Pythagorean triple, this is a 6, 8, 10 Pythagorean triple. So a couple different ways to do that, but this height is going to come out to 6 using the Pythagorean theorem or the Pythagorean triples. And so then this comes out to 4 squared is 16, times 6 is 96 pi. So we're getting 96 pi units cubed. Remember, with volume, it's always going to be a three-dimensional. Cubic units is what's filling up the interior of the shape. Now, if you want to find the surface area for a prism or a cylinder, we use this formula. It's the area of the base times 2, because we have two bases. You can see the top and the bottom, plus the perimeter of the base times the height. Now, the perimeter of the base in this case would be like the circumference times the height. Sometimes it's helpful for students to draw a net. If you were to cut this and unfold it, what you would get is you'd get like a rectangle like this, and then you'd have the two bases, which are like the two circles here and here. So the area of the base, let's go ahead and write down the general formula. I'll show you. So in this case, we have surface area equals area of the base times 2 plus the perimeter of the base times the height. Again, because we have the base as a circle, we're going to do pi r squared. The perimeter of the base represents the circumference, which that's going to be 2 pi r, and then times the height. Okay, so now let's go ahead and substitute. We've got the radius, which we said was 4, so that's 4 squared. We have the radius here again, which is 4, and then the height we said was 6. Okay, so if we simplify this now, we get 4 squared is 16, times 2 is 32 pi, plus we've got 4 times 2 is 8, times 6 is 48 pi, and if we add these together, we get, let's see, 80 pi, and that's going to be units squared is our surface area. Now again, just so you can see this circumference here. If I was to cut this cylinder and unroll it, see, this dimension here becomes this dimension here. That's the circumference or the perimeter of the base. When you multiply it by the height, you're getting the area of this rectangle, and that's what we call the lateral area. Then you just add on the two bases, and that'll give you the total area, which is the surface area. So let's take a look at example number 2 now. How would you find the surface area and the volume of this cone? Well, with a cone, we use these two formulas. Volume equals 1/3 area of the base times the height. Let's go ahead and write that down. 1/3 area of the base times the height. Capital B means the entire base. The base is a circle though, so we know the area of a circle is pi r squared. And here we know that the radius is 5, so that's 1/3 pi times 5 squared. And then the height, we have to figure out what that height is. This 13 is actually what we refer to as the slant height, or like the leaning height. We want this perpendicular height right here, and I can see that this is a 5, 12, 13 Pythagorean triple. You can do the Pythagorean theorem if you want, a squared plus b squared equals c squared, but I recognize that this is a 5, 12, 13 Pythagorean triple, so we've got our height, which is 12. And if we simplify now, let's see, we've got 25, 5 squared is 25, 1/3 times 12 is 4. 4 times 25 is 100. So we're getting 100 pi units cubed. That's our volume. Now, if we want to find the surface area, we're going to use this formula. It's the area of the base plus 1/2 the perimeter of the base times the slant height. Now, the base is a circle, so we're going to do pi r squared. The perimeter of the base, that's the circumference, which is 2 pi r. And then the slant height, that's this height right here, the diagonal or leaning height. So you can see 1/2 times 2, that's 1, so that cancels out. So this formula actually simplifies down to pi r squared plus pi rl, but I like to just memorize kind of the general formula, less to memorize, and then you can put in the sub formula and kind of customize it to the particular figure you're working with. So in this case, the radius we have is 5, and the leaning height or the slant height here is 13. So if we go ahead and simplify, this gives us 65 pi plus 5 squared is 25 pi. That comes out to 90 pi units squared, since area is square units. So let me erase the whiteboard. Let's do the next group of problems. Okay, see if you can do number 3 and 4. Find the surface area and volume as an exact answer if possible. If not, use your calculator round to the nearest 10th or 100th place. But for number 3, what kind of a shape are we dealing with here? Looks like we have a hexagonal prism. So if we want to find the volume of our prism, we're going to use this formula here, area of the base times the height. So capital B means area of the base times the height. In this case, when we're dealing with a regular polygon, we can use the sub formula 1/2 the apothem times the perimeter. And then we're going to take that and multiply it by the overall height. Now, in this case, the perimeter, you can see the side length is 4 times 6 sides. That's going to give us a perimeter of 24. The height we know is 8. All we have to do now is find the apothem. Now, what is the apothem? The apothem, you remember probably from earlier in your class, it's basically this distance right here, perpendicular from the center to the side. So you don't want this dimension, that's the radius. But what you can do is you can divide up that hexagon. This is not a perfect hexagon, but basically divide it up into congruent triangles. And if you take 360 divided by 6, since there's 6 triangles here, that'll give you a central angle of 60 degrees. Now when I drop that altitude or that apothem, that's going to bisect this angle, making it a 30-degree angle. So I'll make this a little bit larger. So this is 30 degrees. This is bisecting the side, so instead of 4 here, this is going to be 2. And we've got a 30, 60, 90 special right triangle. So knowing what we know about special right triangles, x, x root 3, and 2x, this apothem here is going to be the short leg times the square root of 3. So this will be 2 root 3. If you need help with special right triangles, I've got videos on my Mara's Math Tutor YouTube channel on 30, 60, 90, and 45, 45, 90 special right triangles. Check out those videos for more understanding of how this works if you need help with that. So that's going to be our apothem right here. So that's going to be 2 square root of 3. So if we multiply that together to get our volume, we get, let's see, I'll use the calculator a little bit here. So we have 8 times 24, and then 1/2 times 2 is 1. So this comes out to 192 square root of 3 units cubed. That's going to be an exact answer for your volume. See how that square root of 3, if you do it on your calculator, square root of 3 is like 1.7 something, right? So that's exact. And then if we want to find the surface area of a prism, we use this formula, area of the base times 2, since we have 2 hexagons here, plus the perimeter of the base times the height. Now the area of the base, again, it's a regular polygon. It's going to be 1/2 apothem times perimeter. And then the perimeter, we know, we'll just leave that for right now, p times h. So let's go ahead and put what we know in. So 2 times 1/2, that's 1. The apothem we figured out was 2 root 3. The perimeter we said was 4 times 6 sides, that's 24. This perimeter here, same thing, 24. And then the height, which is 8. Let's see what that comes out to. So we have 48 root 3. And then 24 times 8 is 192. And this is going to be units squared since it's area. So that's an exact answer for the surface area. Okay, for number 4 now, what kind of a shape are we dealing with here? We want to find the surface area and volume. Well, this is a pentagonal pyramid. So we just have the one base. It's a regular pentagon. And how do we find the volume and surface area? Well, let's start with volume. So volume equals 1/3 the area of the base times the height. Now, the height, they give us that perpendicular height right here, that's 24. We've got the 1/3. The base is a regular pentagon. We can use the formula 1/2 apothem times perimeter. We need to figure out the apothem. Oh, they actually give it right there, that's 7. So apothem is 7. We just have to find the perimeter. So let me look at this pentagon a little bit larger here. Remember, we can divide this up into congruent triangles. 360 divided by 5 triangles gives us a central angle of 72 degrees. If we drop an altitude, that's going to bisect that angle. This is going to make this a 36-degree angle. This apothem is 7, and if we do the trigonometry here, we can find this missing segment right here. Tangent is opposite over adjacent, so we'll say tangent of 36 equals x over 7. Multiply both sides by 7. This one we're going to have to use the calculator on, so tan 36 times 7. I'm getting about 5.08. I'm going to multiply that by 2 to get this whole side length here. So this whole side length is about 10.17. But I really need the perimeter, so I'm going to multiply that by 5. So I'm getting about 50.86. So that's this perimeter right here, 50.86. Okay, so if we multiply that together, we get 50.86 times 24 times the apothem, which is 7, times 1/6, gives us approximately 1,424.08 units cubed. That's our volume. Now for our surface area, we're going to use, since it's a pyramid, we're going to use this formula right here. We're going to say the area of the base plus 1/2 the perimeter of the base times the slant height. Now the base, again, we know it's a regular polygon, so we can do 1/2 apothem times perimeter. And so if we substitute in a little bit further here, just move this over here. This is 10.17 for a side length. We've got 1/2 the apothem, which they tell us is 7. The perimeter we said was 50.86 plus 1/2 the perimeter, again, 50.86, times the slant height. Now the slant height, we're going to have to draw this in right here. It's basically the height of one of these triangles here that makes up the sides of the pyramid. And I can see that this is a 7, 24, 25 Pythagorean triple. You can also do the Pythagorean theorem, 7 squared plus 24 squared equals c squared. Okay, so if we simplify this now, we've got, let's see, 0.5 times 7 times 50.86 plus 0.5 times 50.86 times 25. Okay, so I'm getting approximately 813.76 units squared. So that'll be the surface area. Let me erase the whiteboard. Let's do the next group of problems. Okay, see if you can try number 5 and number 6. For number 6, we want to find the volume of this composite solid. And notice that this cylinder has been drilled out of this trapezoidal prism. But for number 5, it says, given the surface area of a sphere is 196 pi meters squared, find the volume. So when we think of a sphere, it kind of looks like a beach ball, more or less, right? Okay, and it really is just composed of that one dimension, the radius. And so what we're going to do is we're going to start with our surface area formula. They tell us the surface area is 196 pi meters squared, and that's equal to 4 pi r squared. We're going to use this to solve for the radius. So if I divide both sides by 4 pi, that comes out to, let's see, the pi's cancel. 196 divided by 4 is how much? 49. So we get 49 is equal to r squared, and if we take the square root, we can see that our radius is 7. But to find the volume, we want to use this formula, 4/3 pi r cubed. We're going to put 7 in place of the radius, and we're going to simplify. So 7 cubed is 343, and so we have 4/3 times pi times 343. Now, here's a little technique. Sometimes when I have a whole number, I just put it over 1 to treat it like a fraction, so I can multiply the numerators together and the denominators together. It just kind of helps everything line up a little bit nicer. So this comes out to 1,372 pi over 3. And that's going to be meters cubed since it's volume. So that's an exact answer for your volume. Now for number 6, we've got, again, a trapezoidal prism, and this is actually, this trapezoid is an isosceles trapezoid because you can see these two sides are congruent, and we want to find the volume. But when it's a composite solid like this, we're going to find the total volume, and then we're going to subtract off the cylinder that's being like drilled out or removed. So when we find the volume of a prism, we're going to use this formula right here, the area of the base times the height. But when we think of the area of the base, that's the area of this trapezoid, right? In the area of a trapezoid, it's 1/2 base 1 plus base 2 times the height of the trapezoid, then times the height of the prism, okay? That's this h here. Now, what's interesting about this problem is you see we've got a 45, 45, 90 special right triangle. If this height of the trapezoid is 3, okay, let's put that in there, this dimension here will also be 3 because the two sides of a 45, 45, 90 triangle are congruent. The hypotenuse would be 3 root 2, but we really don't need that dimension. So what I can do is I can drop two perpendiculars here. This is going to be 3 as well. This is going to be 3. And so that means that if this is 6, this would be 6 plus 3, that's going to give us 12. So this whole base here would be 12 plus this base of the trapezoid is 6 times 1/2. Okay, and then we're going to multiply by the height of the trapezoidal prism, which is 8. Okay, so now we've got it. So 6 plus 12 is 18, times 1/2 is 9, times 3 is 27. 27 times 8 is 216, and this is going to be units cubed because it's volume, but we're going to subtract off the cylinder. Now the cylinder, we're going to use this formula right here. It's the area of the base times the height. The base is a circle, so that's going to be pi r squared times the height. The radius of the circle they're telling us is 1. The height here is going to be the same as the height of the trapezoidal prism. So this comes out to a 1 squared, which is 1, times 8. That gives us 8. So this is 8 pi. So if you want an exact answer, 216 minus 8 pi units cubed would be the volume of this composite figure. Let me erase the whiteboard. Let's do the next group of problems. You can do number 7 and number 8. For number 7, it says the volume of two similar cones are in the ratio of a 125 to 8. If the surface area of the smaller cone is 60 pi centimeters squared, find the surface area of the larger cone. So how would you do that one? Well, one thing that I notice is that this ratio is the ratio of the volumes. When I think of volume, I think of three-dimensional, right? So what I'm going to do is I'm going to take the cube root of 125 over 8. The cube root of 125 over 8 is 5 to 2. Now 5 to 2 is the ratio of the corresponding side lengths, okay, or the one-dimensional ratio. But I want to compare the ratio of the surface areas, which is two-dimensional. So I have to take that scale factor, or that, I shouldn't say scale factor, but the ratio, and square it. So if I square that, that's going to give us a ratio of 25 to 4. So comparing the two surface areas, they're going to be in a ratio of 25 to 4. 25 corresponds to the larger cone, 4 corresponds to the smaller cone. The surface area of the smaller cone is 60 pi centimeters squared. The surface area of the larger one we don't know. So again, remember, 25 is larger than 4, so we have large to small, large to small. Sometimes students don't know how to set this up. That's a good way to kind of approach it. You can then cross multiply 4x equals 25 times 60 pi, which is 1500 pi, divided by 4, which is how much? 375 pi centimeters squared. So that would be the surface area of the larger cone. For number 8 now, it says find the volume and surface area of a hemisphere with a radius 6 inches. I always like to draw a diagram most times just to kind of visualize. So here's something like half of a sphere, right? Hemisphere means you're cutting the sphere in half. And it tells us that the radius here is 6 inches. So if we want to find the volume, we know the formula for volume is 4/3 pi r cubed, right? But we want just half of that volume since we're cutting it in half. So half of 4/3, you could reduce this and think of this as 2/3 pi r cubed, and the radius is 6. 6 cubed is 6 times 6 times 6, that's 216. Times 2 is 432. Divided by 3 is 144 pi inches cubed. So that's the volume of the hemisphere. Now, if we want to find the surface area, here's where students can make a little bit of a mistake. You can see the surface area is 4 pi r squared. Students will say we cut that in half, so shouldn't it be 2 pi r squared? Well, think about an orange, for example. If you had like the rest of the orange, right, and you cut it in half, this top half, okay, would be 2 pi r squared. But because when you cut it, now what you're doing is you're exposing this circle here, which is on the interior when it's a sphere, but now it's exposed when it's a hemisphere. So what you have is 2 pi r squared plus this circle, which is another 1 pi r squared, gives us a surface area for this hemisphere of 3 pi r squared. Do you follow that? So pi times 6 squared times 3, this is 36. 36 times 3 is 108 pi inches squared. So let me erase the whiteboard. Let's do the last two problems. We can do number 9. It says, given the two similar cylinders, find the volume of this larger cylinder. And notice that we're given the height is 4 centimeters. The height of this one is 12 centimeters, which tells us that the ratio is 1 to 3. If we reduce 4 over 12, that's 1 to 3. But when you're comparing volume, you have to cube that ratio to get the ratio of the volumes. 1 cubed is 1 times 1 times 1, which is 1. 3 cubed is 3 times 3 times 3, that's 27. So the ratio of the volumes is going to be 1 to 27. And again, you're comparing small to large. See, 1 is smaller than 27, so small to large. The smaller volume is 16 pi to the larger volume x. If we cross multiply, 1 times x is equal to 27 times 16 pi, which comes out to 432 pi centimeters cubed. That's the volume of the larger cylinder. Now for number 10, last problem, it says a beach ball with a radius of 1 foot holds the same amount of water as a cylinder tower of water with radius 6 inches. Find the height of the tower. So let's just draw a little picture. We've got this beach ball. It has a radius of 1 foot and it has the same volume, we'll just say equals, this tower, cylindrical tower, and we're trying to find the height of the tower, and this one has a radius of 6 inches. So let's write that as 6 inches. Let's make this a foot, which is going to be 12 inches. And what's interesting is that the two volumes are the same. The volume of a sphere we know is 4/3 pi r cubed, and that's going to equal the volume of the cylinder, which is this formula here, area of the base times the height. The base is a circle, so that's pi r squared times the height. Let's put in what we know. Here the radius is 12. Here on this side the radius is 6, but we don't know the height. That's what we're solving for. So if we divide both sides by pi, the pi's will cancel. Let's simplify a little bit here. So we've got 12 cubed times 4 divided by 3. That's 2,304. 6 squared is 36h. If we divide both sides by 36, our height is coming out to 64. So that means the height is going to be 64 inches, and you got it. So great job if you're able to follow this surface area and volume of 3D shapes test review. If you want more practice or you want to see more about where these formulas come from and how to kind of visualize this in 3 dimensions, I have another video where I talk about lateral area, surface area, volume, and I kind of show you a little bit more about the formulas. If you're interested, follow me over to that video right there. We'll get some more practice. I'll see you there.